Hello, everyone. In this session, we'll be discussing about the cardinality of a set or the cardinal number of a set and some special types of sets based on cardinality of a set. All right. So we were already talking about this cardinality of a set in the previous session. But again, in this session, we'll just talk about this cardinality with the clear definition. So what is cardinality? Cardinality of a set. The number of elements present in a set is called cardinality of a set. For example, we'll take an example here. Let's say, what is the cardinality of a set? And the set is formed by taking all prime numbers less than 10. So here first, we'll just form the set of prime numbers less than 10. So what are all prime numbers less than 10? So what does it mean by prime number? The number which is divisible by the number itself and 1, right? So 2, 3, 5, 7 are the prime numbers less than 10. So this is the set we got. So let's name this set P, let's say. Now let's try to understand what is cardinality here. Cardinality means the number of elements present in the set. So how many elements are there? 1, 2, 3, 4. 4 elements are there. So the cardinality of this particular set is 4. And we represent the cardinality as n of the name of the set. So n of P, here the set name is P. So n of P is equal to 4. This is the cardinality. Or else we can even say this is cardinal number. Cardinal number. Or you can even call this as length of set. Length of the set. All right. So that's all about cardinality. Clear? Now we'll be doing some questions based on this cardinality. I will be having 6 questions here. We'll be discussing about all these 6 questions. All right. And then we'll be having an exercise. Now, before doing those questions, there's something that we have to talk. As I said, there's some special types of sets based on cardinality. All right. So first thing here we have to understand. There are some sets where we cannot find the cardinality. Any example? Let's say set of natural numbers. So how many natural numbers are there? Infinitely many. So how are we going to form the set? 1, 2, 3, 4, 5, 6, and we keep like and so on, right? There are infinitely many elements. So what is the cardinality of this set? We cannot count them. So we cannot say what is cardinality here. So in the aspect of finding the cardinality, finding the cardinal number, there are 2 things. Can we count the elements in the set or cannot we count? So if we can count, then we call the particular set finite set. So we can count the cardinality here. Okay, we can count the cardinality. I mean, we can count the elements in the set, so which means we can tell the cardinality. What is exactly the cardinality of this particular set? Now, in the same way, can we count the cardinality of the second set, the set of natural numbers? We cannot, because there are infinitely many elements. So we call this particular set infinite set. Okay. Infinite set. Here we cannot count the number of elements present in the set. So we cannot tell the cardinality. All right. And there are 2 more sets that I want to highlight here. A set having only 1 element. So the cardinality is 1. If the cardinal number is 1, then there is a special name for this. If the cardinal number is 0, which means having no elements, okay? So how that set would look like. So we'll see. We have some examples for that. We'll just try to understand. So if the cardinal number is 1, we have a name. If the cardinal number is 0, then we have a name for that. So if the cardinal number is 1, then we call that Singleton set. If the cardinal number is 0, then we call that empty set, or we call that a null set, or we can even call that a void set. All right, good. So now we'll do some questions based on this. So if there are any observations here, we can actually take any observations. So let's say my question is, can a singleton set be considered as a finite set? Yes, it is. We could count it. We could say that the number of elements in the set, which means the cardinal number is 1. So we could count it. So it comes under finite set. An empty set can be a finite set. Yes, we could count, and we are saying that there are no elements. So we are clear on the count, right? So yes, it comes under finite set, right? So good. So without any delay, we'll start the problem solving stuff. So what is the first question here? Set of even prime numbers. All right. So what are all even prime numbers we know? So what are all prime numbers we know? 2, 3, 5, 7, 11, 13, 17, 19, and keep going. If we are talking about prime numbers, there are infinitely many, right? But the question is even prime number, the only one, the first prime number, which is 2. So that is an even, right? This is what? Even prime number. So we're going to form a set with even prime number. So only one element will be there, and the element is 2. So you can name this set, let's say A. So what is the cardinality of this set? N of A is 1, right? So here 2 observations. We could count the elements. So it is a finite set. All right. And the cardinal number is 1. So the special type, it is a singleton set. Clear? And the second question, X says that X is equal to root 25 and X belongs to natural numbers. Okay. So they said that X belongs to natural numbers. So which means X is some of the elements from 1, 2, 3, 4, 5, 6, 7, 8, and so on. These are the set of natural numbers. All right. Fine. But we can consider some of these natural numbers, very few natural numbers, which satisfies this equation. So what is the equation here we have? X is equal to root 25. Okay. Which means, what is root 25? It can be plus 5 or minus 5. So now my question is, can we form a set with the elements what we got, X values, as 5 and minus 5? Is this the answer for this question? No, it is not the answer. Then what's the solution? Now focus on this. X must be from natural numbers, but minus 5 is not from natural numbers. So that's the reason it is wrong. So what we do is we avoid this minus. We just take only positive values. So 5 is the answer. So you can name this set B. So what is the cardinality? Is 1. So we could count the elements. We can say that it is finite set. And moreover, the cardinality is 1. So we can even say that the singleton set. Good. That's it. And the next question. Set of negative numbers in natural numbers. So what are natural numbers, first of all? 1, 2, 3, 4, 5, 6, all counting numbers, right? So there are infinitely many natural numbers. Now we have to bring negative numbers from this set. Are there any negative numbers in natural numbers? Any negative numbers in counting numbers? No, there are no negative numbers in counting numbers. So what is the set here? What are the elements in this set? No elements. There are no elements in this set. That's it. Yeah, it's clear. There are no elements. We cannot write any elements in this, and we can name it, let's say C. So what is the cardinality of C here? is 0. Sometimes you make mistake, like there are no elements, so 0 elements, right? There are 0 elements, so I will keep 0 here. No. If you keep 0 here, it says that 0 is a negative number from natural numbers. But it doesn't make sense, right? So 0 is neither positive nor negative, first of all, and it does not belong to natural numbers, right? So this contradicts the truth that it does not belong to a natural number and it is neither positive nor negative. So what we do here, we do not write anything. So that's how we have to leave. But the cardinality is 0 here. Agree? So we could say the count, which is 0. So can we say this a finite set? Yes, it is a finite set. And what is the cardinality? Is 0. So we say this empty set. All right. Now, there are some special notations for empty set. So you can denote an empty set simply something like this, like the way how we wrote the answer. Or you can even represent this as phi. Okay. The sign is you want to keep 0 and then a cross sign. So this is how we represent phi. All right. So an empty set can be represented something like this. So this is how we can write the answer. Clear? Right? The next question. Multiples of 15 between 91 and 100. Okay. So what are the multiples of 15? 15, 30, 45, 60, 75, 90, 105, 120, and it's keep going. Now our focus is in between 91 and 100. Are there any elements between 91 and 100 belongs to this elements? No, there are no elements between 91 and 100 present here, right? And if you see, 90 is one of the multiple of 15 and 105 is one of the multiple of 15, and 91 and 100 belongs to something in between this, but there are no numbers between these two present in multiples of 15. So we can say that there are no values, no multiples of 15 between 91 and 100. Okay. So what do you think the answer? Null set. That's clear. So you can simply put null set. That's it. Or else you can even write something like this. Okay. And if you name this something like D, then what is cardinality of D or cardinal number of D is 0. So based on this, we can say that it is finite and it's an empty set. All right. Clear. Now, next question. Natural numbers less than 10. All right. So what are the natural numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and so on. Right. But we have to pick only the numbers which are less than 10, which means these numbers we have to consider. So form a set with those numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. That's all. Yes, name this set E and we can count the elements. There are 9 elements. So cardinality is 9. So we can say that it is a finite set. Right? And it can be anything else. Can it be a singleton or empty? No, it cannot be. It's just a finite set. And it's obviously, if it is a finite set, then it cannot be an infinite set. All right. Next question. Next question says that, oh, numbers, natural numbers greater than 10. So the previous question is less than 10. In this case, it is greater than 10. So greater than 10 means we have to consider the greater than side. So right hand side of 10 on natural numbers list. So which is 11, 12, 13, 14, 15, and so on. So form the set 11, 12, 13, 14, 15, and it's keep going. Can we count? How many are there? It's going infinitely many, right? So we cannot count the materials here. So we cannot count the elements. So it is an infinite set. Clear? right? So these are all solved problems here. And now I'm going to give you an exercise. So this is the exercise here we have. And we have 8 questions here. All right. So as usual, just pause the video and try to solve all of these questions and then come back and then cross check with your answers. All right. Okay. What's the first question here? We have to figure out how many of these sets are empty, how many of these sets are singleton, finite, and infinite. So the first part of this first question, set of letters in English alphabets. So it's how many English alphabets are there? So we know all the English alphabets, A to Z, and there are 26, right? So we can count them. So what is the cardinal number here? 26. Right? We can count them. So it comes under a finite set. Agree? So it is a finite set. Can it be empty or singleton? No, they have elements and that is not just one. Right? Cool. So it is just a finite set. Next, the second question. Set of integers less than 5. Okay. So what are all the integers? We're going to take natural numbers along with 0. And then we're going to take negative of natural numbers. Then yes, these are integers. Now we have to consider the integers which are less than 5, which means from 4 towards left-hand side. So how many are there? There are infinitely many. Can we count them? No, we cannot count them. So it comes under an infinite set, right? So a set of integers less than 5 are infinite. Okay. Next, the third question. Set of concentric circles. So what does it mean by concentric circles? Circles having same center. For example, this is the center and I can draw a circle and the radius is, let's say, R1. Now let the circle be C1. Okay. Now can I draw another circle with the same center? Yes. I'll just increase the radius here. I'll increase the radius and I'm going to draw another circle. So I can draw another circle with different radius, but the same center. And in the same way, how many circles I can draw? Just by changing the radius value, I can draw infinitely many circles, right? So these are all circles are called concentric circles having the same center. All right. So if I name this circle C1, C2, C3, C4, so I can form a set saying that C1, C2, C3, C4, C5, and I can form infinitely many circles. So it's an infinite set. Agree? So we cannot count how many circles we can draw here. We can draw infinitely many circles. So what we say, this set is an infinite set. So the third one is an infinite set. All right. Next, the fourth one. Natural numbers between 3 and 4. So the natural numbers are 1, 2, 3, 4, 5, 6, and so on. Now, between 3 and 4, how many natural numbers are there? There are no natural numbers in between 3 and 4, right? There'll be rational numbers between them, right? The fractional form numbers. And there can be an irrational number, but there are no natural numbers between 3 and 4. So there are no elements. So the cardinality is what? The cardinality here is 0, right? So we can count the elements and the count is 0. So we can say that this is a finite set because we could count it. And then the count is 0. So it is an empty set also. All right. Good. Next question. Digits in decimal number system. Okay. So first try to understand what is decimal number system. The number system, what we are using for our calculations or for any mathematical or any count, the system what we are using is decimal number system. We are not using binary, hexa, octa or something. Those are all computer languages, right? We use decimal number system. So in decimal number system, if you take any number, the digits in the number are out of 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. So you can form any number using the digits from this list. Agree? So how many digits are there here? There are 10 digits here, right? So what is the cardinality here? 10. So we could count the elements. So it is a finite set. Agree? So it is a finite set. Can it be an empty or singleton? No, it can't be an empty or singleton. It's more than one, right? So it's just finite set. That's it. Now, sixth question. Sixth question is kind of interesting. Just follow this. Set of numbers that we cannot consider for Q in P by Q form. Okay, so our focus is on P by Q first here. So what is P by Q form? To represent a rational number, we say that it should be in P by Q form. Agree? So rational number or a fractional form. A fractional form. Okay. To write a number in rational form or fractional form, we make sure the denominator should not be equal to 0. Agree? And the question here that they are asking, what are the elements that we cannot consider for Q? Yeah, for Q, we cannot take 0. Only one element that we cannot consider for Q. What is that element? What is that number? 0. 0 is a number we cannot consider. And they are asking for cannot condition only. It's not like what we can. If they say what we can consider for Q, infinitely many. But the question is cannot consider for Q. So 0 is the only element that we cannot consider for Q. Right? So how many elements are there in this set? Only one element. The element is 0. Right? So we can say that only one element, which means we could count. So it is a finite set. And the element is 0 and the count is 1. So it can be a singleton set also. Yes, it is a singleton set. Right? So careful here. The cardinality is 1. The element is 0. That's okay. So this empty set and singleton set are named based on their cardinality, not based on the element, right? So the cardinality is 1, so it is a singleton set. Next question, seventh one. Okay, seventh one and eighth one are almost similar, but only one difference, that the seventh one is from integers and eighth one is from whole numbers, the x, right? Okay, we'll work on seventh one first. So x belongs to integers, means let's say all the negative natural numbers here and 0 and natural numbers. So these are all called integers. Okay, and the mathematical expression is x squared minus 100 is equal to 0. From that, x squared is equal to 100. From this, we can say that x can be 10 or minus 10. So we can form a set here with this 10 and minus 10. These are the solutions. That's what they're asking. They're asking us to write x. But before writing that, just cross check. Does this 10 and minus 10 both belongs to integer? Yes, it does. 10 and minus 10 both belongs to integer. So no problem. The answer is 10, minus 10. Right? So what is the cardinality here? 2. So we could count the elements. So we can say that it is a finite set. Clear? Good. Now, eighth question. In eighth question, what happens? The same solution and almost the same set, but one thing that we have to understand, 10 does belongs to whole numbers. Whole numbers means what? 0, 1, 2, 3, 4, 5, 6, 7, and 9. Natural numbers along with 0. So 10 belongs to this set, but minus 10 does not. So in eighth case, the answer is only 10. We cannot consider minus 10 because minus 10 does not belongs to whole numbers. Right? So the cardinality is 1. So we could count the cardinality. So it is a finite set and the cardinality is 1. So it is a singleton set also. All right. So yes, good. So that's how we can solve these questions, or we can categorize these sets into a finite and infinite. And later on, if the cardinality is 0 and 1, then it is empty and singleton. All right. So moreover, empty and singleton, the finite and infinite are very important in the future work. When you are working on three-dimensional plane and you want to represent materials on set, then finite and infinite are very important at that point. Okay. All right. So that's all for this session. And based on cardinality and the element present in the sets, we can say if two different sets are equal or not, or at least equivalence or not. So now we have to understand what are the conditions here that we have to consider to say that two sets are equal or two sets are equivalence. So we'll be working on this concept in the next session. All right. So that's all for this session. I'll see you in the next session. Bye.